Hi, everybody. I want to welcome you to Cognitell session on retention modeling and prescribed interventions. We're excited to be here at the conference, and we look forward to interacting with folks throughout the conference. So let me introduce myself. I'm Matt Swaffer. I am a technical architect. I have a background in designing and developing software systems and technical solutions. I've been doing that for the better part of 2 decades. In addition, I have a PhD in educational psychology. And so I'm passionate about bringing technical and data solutions and applying them to the science of human learning. Mike Barber is my colleague. He's our data scientist, and he's going to come along in a little bit and talk a little more about the machine learning modeling work that he's been doing in the retention space. Mike has a strong background in industry, and he brings his talents forward and now is applying them in higher education. So a little bit about Cognitell and what we do. We're a data science and analytics company. We focus on the data science side of things, but as you know, if you don't have good data, it doesn't matter whether you're doing statistical modeling or machine learning modeling, your modeling is not going to be effective if you don't have good data. And so we have a strong team of data engineers who work with us to wrangle that data, get it where it needs to be, when it needs to be there. And so we also do those kinds of things. Our focus is in the higher education space, so we understand the data, we understand the environment. So when we bring our data science and our data engineers to the table, we understand what it is we're working with here. I'm going to frame a lot of what we talk about today around the work we've done with the state of Wyoming. The state of Wyoming has a community college commission, and the commission is tasked with working with all 7 of the community colleges across the state of Wyoming. As you can imagine, the state of Wyoming has a lot of rural areas, and many of these schools are smaller, serve disparate populations, and many of them have relatively small IRIE offices. And so the commission, part of what they do is they provide services to help the IRIE offices, and that's a lot of what we are engaged in with the Community College Commission. In the past, one of the challenges that these community colleges have had is with doing the retention modeling work, many of the off-the-shelf solutions that you can get, they're targeted towards larger institutions or different populations of students. And so the models don't always perform well for these smaller institutions. With the varying populations that they have. And so that's one of the challenges that we've been actively engaged in helping with. That's a lot of what the talk today is going to revolve around, is our work in the retention modeling there. In addition to the retention modeling work, Mike has done a bunch of other stuff to help out up there. So he's facilitated this statewide research group with the IRs. He's done data science training for the IRs. He's conducted workshops in R, that kind of stuff. We've collaborated on different projects with the various community colleges. I'm going to talk a little bit about one of those collaborations here in a little bit. I mentioned the data engineering. Our data engineers have helped build some data pipelines to get data from the source to where it needs to be in order for us to do some of the modeling work that we're doing. Mike's going to talk a little bit about some of the LMS data that we've used and incorporating that into some of the models. In addition to those things, we kind of do this typical feature engineering, the machine learning model, development analysis, validation, those kinds of things. So we've done a broad variety of things helping out with the various community colleges. So some of the preliminary results that we've had at the working with the commission and working with the various colleges across the state of Wyoming. One of the challenges, as I mentioned, is that the off-the-shelf systems often didn't work, and many of those, not all of them, but many of them work primarily with SIS data. So they pull in demographic information, GPA, those kinds of things. And one of the innovations that Mike brought to the table up at the state of Wyoming is he started incorporating the learning management systems, so your Canvases, Moodles, those kinds of things. Started pulling that data that I call behavioral data, right? We're looking at actual behavioral behavior of students interacting with these LMS systems. And so he started incorporating that into the models, and turns out some of that data was really useful. Almost half of the features that were engineered or the features that are useful in building these predictive models turn out to come from this LMS data. So some of the important LMS features were things like how often and how long did students interact with the course, and what time of day were they interacting with the course. Those kinds of features were actually helpful. Of course, assignment and quiz activity, discussion topic participation, those things are all important features. And in addition to my technical career, I'm also an adjunct lecturer at the University of Northern Colorado. And I can tell you as an instructor that these things are somewhat intuitive, right? I can tell you that, noticing when students turn in assignments and paying attention to how active they are in discussions, either in the classroom or online, either one, that tells me a lot about student engagement. So some of this is somewhat intuitive, but we're able to take these behavioral ideas and turn them into data that we can incorporate into the model. And so in doing that, Mike's had some pretty good success. So he's improved the models. Mean model accuracy was increased by between 10 and 20%. And then the false positives, this type 1 error rate, which if you're familiar with predictive modeling, that's an important metric. He was able to reduce that by as much as 15%. So these are some really good outcomes with some of the work we've done in the retention modeling. And so we'll continue to talk about the retention modeling. But next I want to talk a little bit about a new project that we're working on that feeds into some of the modeling work that we're doing. Okay, next I want to talk about one of the projects that we've been working with one of the colleges in helping them develop a self-report survey. One of the challenges that we faced with some of the modeling exercises that Mike's doing is when students are brand new, they're brand new student, we have the SIS data, and after a couple of weeks we have some LMS behavioral data, but there's this period of time that's absolutely critical to identifying students who are at risk, where we had basically very little information that was useful to tell us which students might need an intervention or might need a little bit extra coaching or something. And so we decided to address this by developing an intake survey, and there's some other components of this, but this is one of the areas that we've been helping out with one of the colleges. So some of the challenges that they faced with the existing intake assessments, of course, you can go get these off the shelf, you can buy these, and there are plenty of these instruments out there. But some of the challenges that they faced here were that can be relatively expensive to administer, depending on the size of your student population and how many students you want to give them to. But also, they're not really customized for the particular population that they're administered to. So when we were working with the student success folks, they said there's gaps in areas that we would like to ask about, but they're not part of these off the shelf assessments or survey instruments that you can get. And so part of the problem with that is these things might not work for small or rural student populations. They tend to be normed for much larger institutions, broader categories of institutions. And again, there's nothing wrong with being able to compare a student population with other student populations and say, okay, these are normed instruments, and we understand how they compare with other student bodies. And there's a time and a place and a usefulness for that kind of an instrument. But in this case, some of the data uses that we'll talk about here in a minute, it wasn't quite as useful to have that kind of data. So the other problem that they faced was that it was hard to integrate some of this new data into Colleague, which is their SIS system. And so there were some challenges there. So we work with the Central Wyoming College, and in order to do this work, I have a background in psych. I've done psychometric assessment. I understand this field. It's not very useful for me to just go off in a vacuum and develop this instrument. So I worked very closely with the institutional effectiveness and the student success folks in order to understand what they really needed to get out of this data. I started with the research, but then we went back and we iterated over the scales and we said, what else should we include? How do we tailor these things for this particular population so that they make sense to them? Part of this work was they had done some previous work where they had asked students who dropped out or withdrew. They'd asked them, well, what was your reason for doing this? And when I found that out, I was like, well, let's absolutely incorporate that information, because that's on the back end after it's happened. But if we can develop some scales that will help us identify those risks up front, then maybe we can address them early on in the process. So that was part of how we worked on this this assessment. So where I started was in the literature, and I'll come back to this later in the presentation when I talk about prescriptive modeling. But this is work from Robbins et al., and they've done a lot of work around retention modeling and understanding when students are gonna leave school, et cetera. And so they came up with this idea of psychosocial and skills factors. And these are cognitive cognitive skills and just academic skills that students bring to the table. They're characteristics of the individual. And it turns out that they are helpful in predicting retention, but they're also helpful in understanding the interaction of different interventions and how students will respond to them. So they have these different categories here, and I'll go into more detail later, but motivation and skills, of course, important to human learning. Self-regulation, like self-regulated learning is kind of the holy grail of human learning. The social engagement, we know that human learning is inherently a social activity. And so these are kind of the categories, and then within these there are different, very, very specific things. Like want to look specifically at academic self-efficacy and how that relates to self-regulated learning and those kinds of things. So this was kind of the starting point. And then what I did is I sat down with the IE and student success folks, and I said, okay, of these, which ones resonate with you and your work with the students? And so we narrowed this list down, and we said, okay, we're going to develop scales around these particular factors, right? And we believe these are the ones that are the most important for this group of students. In addition to that, we developed these population-specific constructs. And so, I mentioned the drop withdrawal reasons. We developed a scale, or actually several scales, from those drop withdrawal reasons. We kind of categorized them into things like health and logistics and those kinds of things. And we developed scales around those specific things, again, with items tailored specifically to situations that their students would understand, right? And so that was part of this. And of course, right now, COVID-19 is the elephant in the room, and it's impacting everything in higher education. And so again, what we did is we developed a set of questions, a scale around COVID-19, and talked through how it might intersect and interact with these specific students and the population of students that they have at CWC. So when we walked away from this, we had what we felt like was a very tailored survey, tailored to this population, that would give us some good data. So what are we going to do with the data? And this is, I'm presenting it last, but this is kind of one of the first things you do when you're doing something like this is, what are we going to do with the data? What do we need to end up with at the end? And at the end, what we want to be able to do is we want to be able to coach individual students. And that's one of the stated goals. We want to be able to have a dashboard that says, this student has these strengths and potentially these weaknesses, and how can we capitalize on those strengths and help these students out, right? So that's one of the stated goals here. In addition to identifying trends, so we'd like to be able to see, does academic self-efficacy change over time as students move through the program, right? And then lastly, the predictive analytics component, being able to predict whether or not a student's going to persist into the next semester is an important tool for the student success folks to have. So I'm going to turn it over to Mike now, and Mike's going to talk about how he thinks about incorporating this data as well as all the other data sources into his predictive modeling efforts.
Hey, thanks, Matt. As Matt was just saying, my name is Mike Barber, and I'm a data scientist for Cognitell. I mainly work within the educational space. And today I'm here to talk to you about the importance of combining disparate data sources, and especially the importance of doing so for modeling student success. So we're going to talk initially about why. Why is it important to combine all of the data that you can find? And then we'll talk about some techniques techniques that I've applied, basically, and are quite common within this area. And then I'll share with you a couple of learnings of what we as Cognitell have gained out of applying these techniques in multiple data sets and multiple domains. So more context is always a good thing when it comes to modeling. More context allows for additional features or for engineering new features or re-engineering the existing features that you have. So whereas data context and additional context is always good, additional data, more data is not necessarily a good thing, especially if it doesn't contain additional context. So just throwing data at a problem isn't really the solution. So how do you go through and select the items from data sources that are relevant to the problem that you're trying to model? And so the importance of combining disparate data sources and doing this continually is important because feature shift is real, in that the features that are important to monitoring student success one semester may not be important a subsequent semester, etc. So our world is always changing, and so the models that we build should always update as well. And the beauty about the education domain is we have semesters. So semesters are a perfect epoch for reevaluating features as well as retraining your models and retuning them. So how do you combine disparate data sources? You design, you develop, and you prototype a lot of data pipelines. You perform a great deal of statistical experiments. You apply feature engineering continuously to evaluate the contribution of new features or features that you haven't considered before. And you employ feature selection and evaluation techniques. And that's what we'll talk about next, is we'll just kind of give an overview of feature selection and evaluation techniques. So feature selection is primarily focused on removing those data elements, those columns that aren't necessarily informative to your model. They're redundant. Maybe the information is contained in something else. So the reason that you want to perform feature selection and evaluation is because the presence of information that's non-contributory to your model will reduce the certainty of your predictions and the overall effectiveness of your model. So feature selection and evaluation techniques can be broken up mainly into two subgroups: feature selection and then dimension reduction in the form of PCA and ICA, principal components, that sort of thing. And so feature selection itself is broken down into unsupervised techniques, k-means, etc., and then supervised techniques. And so supervised techniques for evaluating the contribution of features are broken down into intrinsic algorithms, wrapper methods, and filter methods. And intrinsic algorithms are just that. They're algorithms that have basically a feature ranking built into them. Those include decision trees, random forests, lasso, etc., GLMNet. Wrapper methods are those methods that basically do forward and backward feature selection recursively. And filter methods, finally, are those statistical methods that you apply to the appropriate data set to try to then identify features that may be correlating to your target variable. Examples of this are Pearson's, ANOVA, chi-squared, etc. So you can see that there's a whole plethora of feature selection techniques that you can throw at this problem. And so some of the things that we've learned in applying many of these techniques are that feature selection and evaluations reduce model overfitting. So if you get the right features into it, you reduce overfitting and your model will generalize better. It improves the model accuracy. If you don't include information in your model that's non-contributory, then the model is going to be more accurate. And it also reduces the model training time. If you have the right feature selection, then you're not churning through thousands or tens of thousands of features to evaluate within your model. So some of the things that we've learned are that there's no one best feature selection and evaluation technique. I use several of them, sometimes concurrently on the same problem. Sometimes one works better given the distribution of the data versus another. And so I would say that another thing that we learned, and that's really important in the application of these techniques, is that you need to make sure that you apply the appropriate statistical test for the appropriate data type. So knowing how to treat categorical variables versus continuous variables, etc. Feature selection is an active part and must be an active part of the continuous modeling process. And features should be routinely evaluated for model contribution. You know, features, again, like I said, feature shift is real, and a feature that may be highly contributory to your model one semester may not be so a subsequent semester. So it's always a good practice to continually evaluate the features that go into your models. So from this, I'll turn it back over to Matt, and he'll talk about taking predictions based upon all of these data sets and turning those predictions into a prescriptive outcome.
Thanks, Mike. I appreciate you walking us through all that. As Mike mentioned, what I want to do in the last part of this presentation is to talk about how do we go from predicting a student is going to drop out to actually doing something about it. And so what we want to talk about is how do we prescribe the correct intervention to best mitigate the risk of a student dropping out. So this is kind of the overall view of what we're talking about. So this is on the left side, this is what Mike was just talking about, where we combine the LMS data with the SIS data with the survey intake data and potentially other data sources to create that context around the student, and then create that predictive model, which results in a prediction. From there, we want to do something with it. And so we're going to combine that back again with LMS, SIS, survey data, other data sources, and begin to build a recommendation engine, a prescriptive model that says, here's the appropriate intervention for this individual student. So to get here, I started with this theoretical model, and this theoretical model comes straight out of Robbins. And so I referenced this earlier when I was talking about how we constructed the survey data or the intake survey. And you'll see some correlation between this model and what we talked about before. Some of the terminology might be a little bit different, but I wanted here to present the model as it was presented by Robbins back, over 10 years ago now. And so that's where you'll see some of the discrepancies. But the idea with this model is, on the left-hand side, you have different categories of interventions. These are different things that the student success folks might put together in order to help students out. So you might have some academic skills training, you might do some self-management workshops, you might do some socialization efforts. These are all interventions. We'll talk about some examples of those. And then on the right side, you have the outcome. This is the academic performance. You want to increase that. And of course, academic performance feeds into academic retention. And so these are the things we want to get. And what Robbins et al. Figured out was in the middle, there are some mediating factors. And these are those psychosocial and skills factors. So it turns out that the individual psychosocial and skills factors mediate some of these interventions in interesting and important ways. And so on the basis of this, I believe we can build a recommendation engine or a prescriptive model that helps us understand which of those interventions on the left is going to be the most useful. So to drill down into this a little bit, let's talk about what these intervention categories look like. So we talk about academic skills. These are kind of things like teaching how to take notes, minimizing learning pathologies like test anxiety, right? You teach somebody how to take tests, give them those test taking skills, you might minimize their test anxiety. And again, if you're familiar with that literature, I just made it sound way more simple than it is. But that's an example of the kind of thing that falls under academic skills. Self-management, here we're talking about things like time management, we're talking about that counseling stuff. This is kind of that individual coaching that I mentioned earlier as a use of that data. The social interventions, these are things like creating learning communities, having social media accounts that the institution runs and that students can interact with. So these are those psychosocial and skills factors that we talked about earlier, and again, slightly different wording from what we ended up using in the survey, but this is the same concept, right? These psychosocial and skills factors are the individual characteristics of the students that we think meaningfully interact with those interventions. Now, we talked earlier about using self-report data to assess some of these things, but what was interesting when Mike and I were talking about how to use some of this data is, what if we can extract some of this information from the student's behavior, right? And again, there's nothing wrong with the self-report data, but my background as in educational psychology, I focus primarily on cognitive psychology and experimental cognitive psychology at that. And so for me, self-report is one set of data, but if I can understand the characteristics of the learner based on their behavior, that's a whole different level of understanding of the student. And so that's where we wanted to take this, was can we somehow infer from some of the behavioral data we have, some of these PSFs that we're talking about. So this is what that looks like. We'll drill down into some of this and give you concrete examples. So let's say we want to look at study skills, and we can look at different categories like time management, preparation for exams, class notes, those kinds of things. Now I can go into the LMS data and I can start inferring some of these skills based on actual behaviors. So the time between the due date of an assignment and when they submit it, right? Do they submit it early? Do they submit it late? Do they submit it right on time? That might be an indicator of time management skills. We could look at, let's say a course has a bunch of practice quizzes out there, and some students use them consistently, other students never use them. Maybe that use of practice quizzes gives us some behavioral insight into the latent trait of preparation for exams, right? So these are different ways that we're conceptualizing being able to take the behavioral data from the LMS and the other systems and infer different psychosocial and skills factors. So some other examples here, we look at this motivation conscientiousness category. We have then drilled down into achievement motivation, goal focus, academic self-confidence, those kinds of things. So maybe for goal focus, this is a student, I'm really focused on graduating, right? So you might look at this and say, well, how does performance in core courses relate to that? Maybe a student who's highly motivated to, they're a CIS student and they're highly motivated to get a job in computers somewhere, and they take those core computer courses and they do really well. Maybe that's an indication that they've got a goal focus, right? So again, these are examples of ways that we think we might be able to extract some meaning or measurement of PSFs based on some of this behavioral data that we already have in our systems. Social engagement is a similar one, right? So we might look at things and say, perceived social support. We might talk about family support. So your first gen or first time full-time students, maybe we look at that as a flag that says maybe these students don't have as much perceived social support because nobody around them has ever done this before. So, and again, this is a theoretical model, so we haven't validated any of this yet, but these are ways that we're thinking about how to use some of this data to extract that information. So going back to the theoretical model then, the idea here is to be able to take the SIS and LMS data and other data sources and infer some of those things in that middle column there, right? So if we kind of understand something about the students' emotional control based on the self-report survey, based on the behavioral data, we understand a little bit about their emotional control or maybe their motivational control, then we can look back and say, we've already got a prediction about the academic retention piece. It might be possible now for us to back our way into saying, well, what we need is a self-management intervention. So this is the theoretical model that Mike and I are working from right now. We're working on implementing it. We haven't implemented it yet, and so we don't have results to report from this. But I think it's an interesting way of thinking about this problem, and it's an example of being able to take the technology and the data and combine them and bring it forward, and hopefully we can help some students have better success in their learning endeavors. Okay, that's all we have time for, so that's it for our presentation. If you're interested in reaching out to Cognitell, finding ways that we can help you out with your needs, we can help with survey customization, data management, data analysis. It's a couple different ways you can get a hold of us. We have a page here at the conference you can stop by. You can download the slides. At the end of the slides, I have a couple pages of references if you're interested in some of the research that I've done in this. You can download some of our brochures, that kind of stuff. You can also set up time to meet with us. There's an email address here, info@cognitell.com. If you want to reach either Mike or me, send an email there, say who you're trying to reach, and it'll get to us. Or you can follow us on LinkedIn and see what we're up to there. So thanks, everybody. I greatly appreciate you coming to our session, and hope you have a good rest of your conference.